morning, good afternoon, good evening to you from whichever part of the world you are. It's wonderful to be here, and I'm Dr. Harsh Verma, Vice President for Global Innovation and Head of IoT Group at R Systems. It's so exciting to be participating and presenting at this Intel IoT DevFest 2 virtual conference. As you can see, we are in 5 time zones, so this is really exciting. So let me switch to the presenter mode. All right, so the topic of this talk is people sense technology, smart sensing and connected pedestrians in an intelligent infrastructure for our autonomous world as part of track 1. And as we are all aware, 50 billion connected things are coming by 2020. And this will need a lot of intelligent infrastructure. So intelligent infrastructure in an autonomous world. This is very exciting. The conversation is a body which talks of the interest and common fantasy for transportation enthusiasts, intelligent transportation systems enthusiasts, and technology optimists for self-driving cars and autonomous vehicles to form the basis of a kind of a safe, streamlined, almost choreographic dance between people, systems, bicyclists, pedestrians, vehicles. So today we see when people want to cross the street, this is what they do. They are standing at the intersection waiting for the walk sign to come. And in an autonomous world, autonomous and connected vehicles, as well as connected pedestrians and bicyclists, need to share the road. So I would invite you to just take a look at this video. Cars, bicyclists, pedestrians, even the cops are moving in a very streamlined fashion. This is really possible in a utopian world. May not be possible right now. Would it be possible in the future? Look at that. I hope the audio also got through, but if it didn't, you could click that link to see that video. In today's world, connected transportation systems and devices lack intelligent processes. With self-driving and connected vehicles, the need for intelligent infrastructure will increase dramatically. As you can see, whether it's a connected car or a self-driving car or any kind of vehicle, when it is coming to an intersection or a blind alley and a pedestrian walking from the other side, so the vehicle needs to know about the pedestrian, and the pedestrian also needs to know about the vehicle. This was part of a panel at the ITS World Congress, and thanks to Toyota for this slide. We need advanced sensing technologies, computer vision and signal sensing, along with AI and machine intelligence. And there is an urgent need to sense pedestrian behavior, pedestrian presence for various user scenarios. So the vision is connected pedestrians and bicyclists. As you can see in this slide, a presentation from IEEE for connected vehicles. Smart sensing is the need of the day for an autonomous world. Intelligent infrastructure, vehicle to vehicle, which has already been tested out in Michigan as part of the US DOT program. Vehicle to infrastructure, intelligent infrastructure, vehicle to network, real-time traffic routing, cloud services, information, edge processing, vehicle to pedestrian, safety alerts to pedestrians and bicyclists. These kinds of scenarios make it the need of the day. In an autonomous world, always alert will be the new norm. To quote Mr. Brian Krzanich, CEO of Intel himself, as part of the future for autonomous driving starts today, a very recent presentation and a public briefing. Connected cars must have the intelligence to quickly react to surprises. So this is a three-step thing as presented here. Evaluating the surrounding environment for reckless drivers or road detours. Quickly identifying options like swerving, braking, turning, or in the future, communicating directly with other car drivers. Also communicating this message to pedestrians, making the right decision and acting on it. So this was the basis for our people sense, a 4-step process: sense and record, intelligent visualization and prescriptive analytics, assess and decide. As you can see, the intelligent visualization and prescriptive analysis are a very closely knit process for providing prescriptive analytics. So let's look at the details and let's look at what are the challenges and implications. First of all, the vehicle and any moving body in an autonomous world, whether it's a car, connected vehicle, self-driving car at various levels, even pedestrians, bicyclists, should be able to sense the environment. Sensor fusion hub for large number of data points is a very important aspect of the required intelligent infrastructure. Early pedestrian detection with intelligent actionable response from the vehicle's point of view. And again, from the pedestrian's point of view as well, we need to see if there's a vehicle coming towards the person, then there needs to be an alert. Use of IoT devices and computer vision. Sensors for LiDAR, sonar, radar, and optical signals. Current smartphone signals are basically Wi-Fi and Bluetooth. So as you can see in some of the illustrations, you can have computer vision for being able to identify pedestrians. You could have LiDAR as in the lower illustration. And with the current cell phone technology, Wi-Fi and Bluetooth. So I'd like to ask the participants who are here in this session, attending this session, to quickly put down in your chat boxes what you think would be the important sensor technologies for today and the coming years, both from the self-driving car, autonomous car point of view, as well as from a human's point of view. LiDAR, sonar, radar, optical signals, Wi-Fi, Bluetooth. Please put down in the chat boxes. It's not a poll, but still it'll be getting information from you. Great feedback. Thank you. So at the next process, intelligent visualization and prescriptive analytics. How do you consume and analyze that data? Look at vehicle to pedestrian conflict resolutions. So as you can see in the illustration on the right-hand side, a pedestrian is crossing the walkway and a vehicle is moving left and could be in the path of conflict. This requires edge processing. And what we have currently, technologies from Intel, like the Movidius neural network compute stack and other systems for providing high compute capabilities at the edge, will be the norm for being able to provide always alert predictive analytics. This would lead to prescriptive analytics, providing people-vehicle automated alerts, reduce pedestrian crashes, and save lives. As we all saw in New York recently, the vehicle hit the bunch of pedestrians and killed people. Our heart goes out to the people, and we hope that pedestrian and bicyclists will be able to have the benefit of intelligent infrastructure to tell them that they need to move, always alert. Prescriptive analytics will also provide flow optimization. As you can see in the other illustration, how people are moving, what are the pedestrian behaviors, what are the walking behaviors, how are people moving. In addition to vehicles, we need to see people sense. So this was the basis for looking at people sense. As the fourth process, assess and decide. which will create the reward and provide a broader societal value. Always alert infrastructure, just like when the mobile revolution came on, it was always on. Today, in an autonomous world, we should be looking at always alert infrastructure, not only for the cars, but for people, bicyclists, pedestrians, and infrastructure itself. Make a decision in real time, lead to edge processing in the future. AI and machine learning will have great importance for this kind of requirements for intelligent infrastructure. And this is going to benefit families, cities, insurance companies, people, everyone in the value chain gets rewarded. So we are going to look as a case study, a typical problem of a city transportation authority where a city event produced congestion. So an event in the city produces congestion, and how we handle this problem. These are some of the typical mass transportation challenges. Events not known to the public transportation departments can lead to buildup of crowds. Suddenly you see there's an event which is taking place at a particular location and crowds are building up over there. Small number of operating trains or buses lead to congestion in the transportation systems. And these problems related to traffic congestion and gridlock could also turn hazardous for commuters. The city infrastructure is not prepared. So how do we handle this? This was a case study which we were able to attack and build up trials in the city of Sacramento. With the launch of the Sacramento Kings on October 4th, 2016, the Sacramento Kings Golden One Arena, Center Arena was launched. And at the time of the launch, with the Paul McCartney show, 20,000 people walking out on the roads after the launch in downtown Sacramento. Not a thing which happened in the past. People walking on the roads in the downtown creates a huge problem of congestion, gridlock, and pedestrian safety. The City Transportation Authority needs urgent planning. We were invited to look at this, and as a joint effort, our systems, Intel Innovator Activity, Global Networks, UC Davis, we have been able to look at how to address this. And with this, look at what could be possible, a different kind of a scenario. Imagine the infrastructure responds dynamically. The regional transport knows when, where, and how many people can be addressed or are there in a crowd. Heavy pedestrian traffic starts building up at a particular location. Unusual heavy pedestrian traffic is detected by the process, the intelligent infrastructure, the people sense technology. And people sense notifies transportation systems of the latitude, longitude, and crowd size. And thus the transportation systems know what kind of shuttle service, buses to send to that location. The idea is to see whether public transportation systems can be made more intelligent to respond to changing transportation demand within minutes, not needing days or weeks of planning, but within minutes. A people sense dashboard can enable city transportation systems to detect this traffic and respond to crowd alerts. So the people sense technology in two aspects helps to have pedestrian density and tracking information acquired by signal sensing. And when you need accurate counts, accurate numbers, then you'd need computer vision. So you just need signal sensing for acquiring crowd formation. And this is what was done as a trial in the city of Sacramento. Real-time data acquired in the city of Sacramento, as you can see over here on the illustration on this left side. The signal sensing data acquired from the city of Sacramento provides you information about the crowd buildup, where the heat map shows the colors for the numbers. a blue color indicates low densities, yellow and green are low densities, and red or orange are high densities. Red goes above a number of people there in the location. So the endpoint applications can view this process sensor data, and machine learning processing integrated with the PeopleSense cloud can help understand possible real-time and historical density data. Inspecting real-time data with a graphical heat map is possible to observe patterns in historical data. The two diagrams on the right-hand side are simulations as to what could happen if we have infrastructure at every intersection to be able to understand crowd buildup. While these were just certain trials, the traffic with the PeopleSense acquired in city of Sacramento. Going to the next slide, just to understand a little bit about the architecture and information flow, building around the Intel architecture and using an Intel NUC gateway, you could have sensor devices which sense signal sensing. These could be various signal technologies. I'm not talking about those right now, but these sensor devices would be basically technology agnostic, and any kind of sensor devices at the edge can send information to the Intel NUC gateway, and counts, location timestamps are sent in a secure manner to a cloud server. For our trials, we've used the Amazon Web Services, AWS cloud server, and data stored on the AWS helps create the PeopleSense dashboard. At www.peoplesense.city, you could see a heat map overlaid on a Google map showing the various trial locations, like the city of Sacramento and others. This is the basic framework for the PeopleSense architecture, and at later stages, you could have more edge processing and computer vision technologies at these edge nodes. With this basic framework and architecture, we look at some of the potential possibilities that PeopleSense can help in optimizing mass transportation usage. So the other use case is when buses and trains go out of schedule due to traffic or other reasons, the commuter traffic distributes unevenly across the transportation systems. Now, people do not know whether to go in that transit, the bus, that they would have to go standing, or take the next bus, which is probably empty. So as the unusual traffic builds up due to suboptimal usage with the transportation systems, while people are standing at the location, PeopleSense enables sending out suggestion alerts to commuters to balance traffic across the transportation systems. Thus, commuters can get the information that they can avoid travel standing in the bus and have a seat in the next one, just 5 minutes behind. These are some of the trials. A smarter city makes a safer city. The trials in the city of Sacramento with Uber data collection, San Francisco transportation management study, and in Las Vegas, the Southern Nevada trials. We have another case example of how the crowd buildup can be located within minutes. This was actually data collected at the Mandalay Bay and other areas and the airport just a few weeks before the unfortunate incident at Vegas. So the crowd buildup monitor on PeopleSense dashboard can be seen over here. Within minutes, the traffic city and the civics authorities could know of a crowd buildup. As you can see over here, this red colored circle indicates a crowd buildup. Within minutes, maybe there are 300, 400 people, it could be configured. And this was one of the use cases we were able to present at the 2017 Fall Transportation Conference in Las Vegas. How can cities and transit be more situation aware to be able to respond to emergencies? So we are very excited that people sense technology can create this basic framework for sensing people and sensing counts, detecting pedestrian presence via signal sensing. As a basic, with the signal sensing, people sense net and people sense views and APIs could provide data analytics and connectivity to subscribers, the regional transit authorities, and a number of various case applications that are building up. People sense CV is detecting pedestrian presence via computer vision. And we are again very excited, in addition to using the basic Intel NUC technology as part of the Intel architecture, we have been able to use the Intel RealSense cameras and smart video for accurate pedestrian counting and tracking performed using 3D computer vision imaging technology. So here you see an actual PeopleSense CV frame from testbed streams conducted at a testbed at the Sacramento State University, where the RealSense camera, Intel RealSense 3D depth sensing camera, is able to accurately inform us number of pedestrians detected too. So we're very excited. 78 US DOT smart city partners have desired this feature, and I would like to see if I can show you this video. So as you can see, the pedestrian detection process taking place using the Intel RealSense. So the two subjects are participating in this test, and as they walk on the pavement, we can see the Intel RealSense and PeopleSense CV technology is able to accurately detect the pedestrians as they're walking through. So we're very excited. We have been able to build a framework, basic framework for PeopleSense density, pedestrian detection via signal sensing, data analytics, and computer vision at a later stage, where you need edge processing and technologies like the Movidius neural compute stick, adding value at the edge. I'd like to give acknowledgements to some of our team members, our collaborators, Professor Michael Zhang, Professor Chenny Chuan, Professor Deepak Ghoshal from UC Davis, Dr. Grace Metry from Intel for helping us with getting some of the components for the trials, Jeffrey Spencer, Executive Director, Sacramento Transportation Authority, who gave us the intent for this need for pedestrian behavior at the time of the launch of the Sacramento Kings. My team members, Dr. Rayford Han from our systems, Nishal Bansal, Avirag Jain, our CTO and EVP, Kapil Jain, Mukund Agarwal, Ashish Gupta, Deepak Sharma, Lokesh Gupta from our systems, and UC Davis team for testing interns, Zongi Lin and Adam Jones. So with this, I would lead to questions, if there are any questions. So yes, I see, thank you for your feedback. Some of you indicated Wi-Fi, Bluetooth are going to be important, Wi-Fi, Bluetooth, and radar. So Bill mentioned Wi-Fi, Bluetooth, and Titi Hunt, Tony, Wi-Fi, Bluetooth, and radar. Kos has asked for the video. I can play the video again since we have some time. I think I can play that video again, which at that time was probably playing without the audio. So, well, you can enjoy this video again. It's more like a utopian scenario where people, bicyclists, vehicles can interact in real time. Just a quick question. What do you think about this futuristic utopian video? Do you think, just a quick question to all the audience, please say yes or no. Do you think that this kind of technology will be possible with the advancements in autonomous vehicle technology, intelligent infrastructure? Yes? Great. Thumbs up. So I see a few questions. Umesh, how effective would be LiDAR and sonar for people sense? I think LiDAR would be definitely the next step to look at for people sense. But where you want accurate count and accurate location of a person, there you need a technology like LiDAR and sonar. And where you just need crowd buildup, for example, as you could see, one of the earlier use cases that we had was where the transportation authority just wanted to know where crowd buildup is happening, where groups of people are reaching out, where is the crowd converging to. There you need just a signal sensing technology. And for accurate locations, you do need LiDAR and sonar, or computer vision. So that's the other question between LiDAR and computer and optical technologies. So Mayur, thanks for the presentation. Thank you so much. Thank you. This was quite informative. Have you done any study regarding LoRa technology in this market? We have looked at LoRa as well. And just trying to understand. That's why we are saying at the edge, the sensing technology, the system will be basically sensor agnostic. So the Intel NUC gateway would collect the people counts and people information, which is the basic container object, from the edge device, which could be anything based on any sensor technology, and then provide this information to the backend. But while this framework is building information, as you could see, one way from the edge to the backend cloud, subsequently, as you require more processing to be done at the edge, you'll require more computer vision or LiDAR kind of technologies. So I hope that addresses the question. Kos, how does the PeopleSense technology be applied in the sensing of the 2-person tested? What would be the limit to count? So it's a good question. We are working on these tests, and while sensing technologies, we've been able to sense, a few hundreds of people with the signal sensing. For computer vision kind of a scenario, we are actually working on these tests to see how many people, what would be the limit to count. So we've started our testing and test beds, and again, thanks to Intel for providing us some of the equipment, and with the Intel RealSense cameras, we have been able to detect very accurately persons, at our test bed located here in Sacramento. We will be working on this. and we'll get back to you with what could be a limit to count. So I think on the utopian video, I see 50%. Some people are saying that yes, that could be possible, and some people are saying no. So it remains to be seen. I feel personally, I mean, people walking through a caravan of vehicles would be quite a dangerous situation. But you know, as technology builds up and we have the capabilities for braking to happen in microseconds, that could be possible. At the same time, we don't want bullying pedestrians or people maybe demonstrating drunken behavior, you know, disturbing the path of vehicles. So that would not be something we look for. You know, but at the same time, it could be a synchronized process that could be possible. Akash, so how does signal sensing work exactly? Is the data collected from the satellite or something similar? No, so it's actually just collected from the sensor node right now. And I think many of you asked about this, so I can pull out the, I can just pull out the presentation quickly to show you. So this is the architecture and information flow, and it pulls information, sensor information from the edge nodes. So we have conducted various trials and various ways for getting this data, including nomadic and fixed sensor devices, which will send data to the Intel NUC gateway. Yeah, we can, absolutely, we can discuss later whenever you could reach out, and we can discuss about your queries for how the data is collected. It's not from the satellite, but it's going directly from the signal edge device to the NUC gateway in the backend. Will E911 calling from a crowd sensed by people sense be beneficial in providing situational awareness to public safety? I think that's a great question, Bill. Let's try to analyze, will E911 calling from a crowd sensed by people sense be beneficial in providing situational awareness to public safety? I think that would definitely be useful if, for example, people sense starts detecting a crowd build up, and there is a E911 call made. This could provide situational awareness for the public safety, and the exact situation could be transmitted by E911 to the first responders. And with next-gen 911 technologies, I think this would be another great thing that could be possible. So definitely be great to touch base and have more discussion on this. Thanks for that comment. Thank you, Bill. Thanks, Kos. So I think your comment is, this technology looks interesting. I look forward to it because its application would really be highly would be really high, especially in rallies, etc. Exactly. Yes, we could see this because of the kind of situation that this was built up for the to really monitor the pedestrian behavior and crowd build up at the time of the launch of the Sacramento Kings Golden One Arena and the Paul McCartney show, where they suddenly saw that there will be 20,000 people. So in such kinds of rallies and things, it would be very useful. Thank you for your comment. Nishal, if we are sharing location, what about the personal information safety? So right now we are sharing location. We are having counts of information, but we are discarding any PII, personally identifiable information. We are discarding any personally identifiable information. We could have signatures of people, just to help understand how the flow is taking place. So that's probably the next project where we have signatures to see that we can have a flow optimization. Thank you for your comment. I'd really like to thank all of you who joined this session. The link to the slides will be available, and we could have those slides available to you. So once again, thank you all for attending this session. Thanks for the opportunity, Intel, to make this presentation. And I'm really excited. This was the second participation in presentation in the Intel IoT DevFest. The first one that was held in June really was very exciting. And with this DevFest 2 taking place in 5 time zones, this makes it even more exciting and interesting, and can present from our living room, participating from our living room. All of you are hopefully participating from your living room or offices, by the way. Thank you very much once again. Have a wonderful day.